Very good afternoon to all and welcome to the class. So, in this class, we are going to discuss isomerism, basically stereoisomerism in detail, because from the coming weeks, we are going to start our organic chapters. So, before starting into the organic, we need to remember certain things, right, related to the organic chemistry, like what is stereoisomerism, why they are important to us, because every year questions are coming from this optical geometrical isomerism. And this is one of the very complex topics, right, of the organic chemistry. So that's why we are starting with this stereoisomerism before starting with your organic chapters, right? So as in today class, basically we are going to see some basic concept of the stereoisomerism, what is geometrical isomerism, what is optical isomerism, and try to solve some numerical as well, right? So this is for the today class. So as you see that stereo isomerism, class 12, we are going to start from today, right? So what is stereo isomerism basically, if I define you? So isomers can be classified into the two type, right? The first one is known as structural isomerism and the second one is known as a stereo isomerism. So structural isomerism means those isomerism which arise due to change in their structure, right? Where the stereo isomerism is basically arise due to change in the spatial arrangement. There how the arrangement orientation are changed, then this type of isomerism is arise is known as geometrical isomerism. ठीक है सबको? और this is stereo isomerism, right? Now in stereo, we have a two type of isomerism that we are going to cover in today class. One is geometrical and the another is optical isomerism. So let's see what is geometrical isomerism, what are the conditions for the geometrical isomerism and all this thing. ठीक है? चलो. So this isomerism which arise due to the difference in the spatial arrangement of group about the doubly bonded carbon atom in case of alkene. If I'm talking about the alkene, then the difference in the spatial arrangement of a group about the doubly bonded carbon atom in alkenes. Like if you have a doubly bonded carbon, then there is a difference, right? There is a difference between these two groups. Either this will be A and this will be A, or this will be B and this will be B. So we're going to see all these things, right? Or single bonded carbon atom in the cyclic compound as well, and doubly bonded carbon and nitrogen atom in oxime. They're talking about the oxime, that is RCN and OH, right? So in case of oxime as well. And doubly bonded nitrogen atom in the diazo compound is called the geometrical isomerism. So this is how we can define the geometrical isomerism. That is this isomerism which arise due to difference in the spatial arrangement of group. Spatial arrangement of group about the doubly bonded carbon atoms in alkenes, single bonded carbon atom in cyclic compounds, doubly bonded carbon and nitrogen atom in oximes, and doubly bonded nitrogen atom in diazo compound is called geometrical isomerism. So I hope this is clear to you what is geometrical isomerism and all. Hmm? Chalo. Next, what are the conditions for exhibiting geometrical isomerism? Right. So what are the conditions for exhibiting geometrical isomerism? So there should be a frozen rotation about the two atoms in the molecule. So this is one of the most important condition, or we say restricted rotation. Restricted or frozen rotation about the two atom in the molecule. For example, if we have alkene, then there is a frozen rotation about CC. This carbon cannot rotate, right? There is a restriction in the rotation. So whenever there is a restricted rotation system is present, then only geometrical isomerism is arise. If this restricted rotation system is not possible, then geometrical isomerism won't arise. Okay, so the first and most important thing for the exhibiting geometrical isomerism is there should be a frozen rotation about the two atoms in the molecules. That is carbon-carbon double bond. That is alkenes. There is a frozen rotation about carbon-carbon double bond. ठीक है? चलो. Similarly, in case of cycloalkane, there is a frozen rotation about carbon-carbon single bond. Right. So in case of a cyclic compound, that is a cycloalkane, there is a restricted or frozen rotation about the carbon-carbon single bond. Similarly, if I'm talking about the imine, that is a carbon-nitrogen double bond, there is a oxime and imine, frozen rotation about the carbon-nitrogen double bond. And in case of HO compound, there is a frozen rotation about the oxime and imine. and double bond. Nitrogen, nitrogen, double bond. So this is the first and the most important condition for exhibiting geometrical isomerism. So I hope this is clear to you. तो सबको clear है क्या? What are the conditions for exhibiting geometrical isomerism and what is geometrical isomerism basically? ठीक है, चलो. Now, geometrical isomerism in alkene, we are going to see, right? So, among the form which are associated with an alkene, the form in which the similar group are present on the same side of the double bond are called cis form. So, in geometrical isomerism in alkene, you need to remember these two names, that is the cis form and the trans form. So, what is this cis and trans form? So, among the form which are associated with an alkene, the form in which similar group are present on the same side of the double bond are called cis form, right? And the form in which the similar group are present on the different sides are called transform. ठीक है? Latin means across and cis means cis का Latin mean क्या है? That is same side. ठीक है? So cis का मतलब होता है same side, Latin का मतलब होता है trans का मतलब होता है across. Okay, so we can classify this geometrical isomerism in alkene in two types, that is a cis form and trans form, in which the similar group are present on the different sides. So if the two similar group are present on the different sides, trans, present on the same side, known as cis. ठीक है, देखते हैं example. So this is known as a cis form. Here we have a carbon-carbon. This is the first criteria. Carbon-carbon double bond must be there. Restricted rotation must be there. Two here we can say having in the same side. So we can say that this is a cis form. Where in this case, A and A having a cross to each other, right? So we can say that this is a transform. Geometrical isomerism is not seen in those forms in which the doubly bonded carbon atom have the same group. So let us assume if the doubly bonded carbon atom having the same group like this. Here carbon having same group, like here also A, here also A. So if they having the same group A and A, so we can that here also they having the same group of A and A. So we can say that this cannot show geometrical isomerism. It means two different groups must be present on restricted rotation carbon, right? So on the carbon, two different group must be present. So that carbon atom have same group attached to it. Clear है यहाँ तक? चलो. Now the conversion of cis isomer into trans or vice versa, that is trans to cis. So the conversion of cis isomer into trans isomer or trans isomer into cis isomer possible only if either of the isomer is heated to a high temperature or absorb light, right? If either of the isomer is heated at a high temperature and they absorb light, the heat supplies energy to break the pi bond. Some example of geometrical isomerism that we are going to see, right? So always remember, whenever you want to convert cis isomer into trans or trans isomer into cis, it is possible only if either of the isomer is heated to a high temperature or if they absorb light. ठीक है? चलिए. Two geometrical isomers are possible for hex 3e. So the two geometrical isomers that are possible for hex 3e. So let us see which two isomerism. The one is, we can say that cis hexene, because we have a ethyl group on the same side, hydrogen on the same side. So we can say that this is a cis hex 3e. Now in this case we have a across we have a similar group, so we can say that this is a trans hex 3e. So this is how we can actually represent cis hex 3e and trans hex 3e. Similar for but 2ene, we have a two things. For example, if we have a but 2ene, then this but 2ene also, so two type of isomerism, like but 2ene means C double bond C, and this is CH3, this is H, this is again CH3, and this is H. So which type of isomerism is this, beta? This is cis but 2ene. This is cis but 2ene. So this is cis but 2ene. Now what is this? carbon double bond carbon. This is again CH3. This is again CH3. This is H and this is H. So same side across, right? So same group across the carbon. So this is known as trans trans but 2-ene. So this is how we can define trans but 2-ene and cis but 2-ene. Clear? So this is the cis but 2-ene and trans but 2-ene. Now, the general point of distinction between cis and trans isomer. So the trans form are the more stable than the corresponding cis isomer. So always remember the trans form are more stable than the corresponding cis isomer. So if you're comparing the stability of cis but 2-ene and a cis and a trans but 2-ene, then always remember the trans form are more stable than the corresponding cis isomer. So if you're comparing the stability of cis but 2-ene and a cis trans but 2-ene, then always remember the trans form are more stable than the corresponding cis isomer. So this is how we can define trans isomer. Please confirm me once whether my screen is visible to you or not. सबको screen visible है क्या? Please confirm once so that we can start our class. फटाफट confirm कर दो एक बार. Yes, very good. चलो. ठीक है. So we are discussing about the right. ठीक है. So we are discussing about some general points of distinction between the cis and trans isomer, right? So the trans form are more stable than the corresponding cis isomer. This point you need to remember always. Why this is? So this is because in the cis isomer, the bulky group are on the same side of the double bond, right? Because if you considering the cis, then what is happening now? Bulky group, that is this is CH3. Here also we have a CH3. This is H we have. This is H we have. So both the bulky group, that is both the methyl group, are present on the same side. So in the cis isomer, the bulky group are on the same side of the double bond. Now their steric repulsion is maximum. So that's why their repulsion is more, right? They repel each other very strongly. So their steric repulsion is maximum, thus making the cis isomer less stable. And it make the cis isomer less stable. Now, melting point of transform is higher than the melting point of the cis form. So this point is also very, very important, beta. The first point is transform are more stable. And the second thing is melting point of transform is higher than the melting point of the cis form. Why this is because? Why? So this is because of the symmetrically packing of the trans compound in the crystal lattice, right? If you see the trans isomer, what is the structure beta? This is CH3 and this is again CH3. This is H, this is H. So they are very symmetrically packed, right? They are very much symmetrically packed. So they are quite symmetrical. कहीं से भी इसको कट करोगे आपको एक symmetrical हिस्सा दिखेगा. So melting point of transform is higher than the melting point of cis form because of the symmetrical packaging, right? Because of the symmetrical packaging. So this point you need to remember. Clear? Now, boiling point. So what about the boiling point? So the boiling point of cis form is higher than that of the transform. Why? Because of the steric hindrance and highly polarity of cis compound, right? So the boiling point of cis form is higher than that of transform because of the steric hindrance, right? Because of the steric hindrance. So always remember, melting point of trans is more than cis, but boiling point of cis form is higher than that of transform because of the steric hindrance and highly polarity of cis compound. Now, move to the next thing, that is solubility. So what about solubility? So solubility of the cis isomer is higher as compared to the trans isomer, right? So if I'm talking about the solubility of the cis isomer is higher as compared to the trans isomer. Why? Because the molecules of trans isomer are more tightly held in the crystal lattice than the corresponding cis isomer. That's why the solubility of the cis is more as compared to trans. So ये सभी points remember करने हैं because many times questions are directly coming out of cis and trans, which will having a maximum boiling point, a melting point, solubility. So this thing is very, very important, right? Now, this is also important thing. That is the cis isomer of the symmetrical alkene. What do you mean by the symmetrical alkene, beta? Symmetrical alkene means they having the equal number of group, whether it's the methyl group on the one carbon, then the methyl group is also on the other carbon. So they have a symmetrical, right? If you cut this, then you'll get this symmetrical, right? If you cut on the middle, you'll get the same part, right? So the cis isomer of the symmetrical alkene has a definite dipole moment, while the trans isomer has a zero dipole moment. Why this is? Because here we can say that this chlorine and carbon, which is more electronegative, chlorine, and here which one is more electronegative, chlorine. So they cancel out each other. So they cancel out the dipole moment of each other. That's why transform having zero dipole moment, right? So why having say zero dipole moment? Because they are placed to two opposite carbon and they cancel out the dipole moment of each other. So we can say that they having the zero dipole moment. Now here also that is a dichloroethane. That is we can say that in this dipole moment of cis is more as compared to the trans. Now, in case of asymmetrical alkene, here we can say that if you cut from the middle, you can get one methyl group above and the two methyl group downward. So this is the asymmetrical alkene, right? So the in case of unsymmetrical alkene, the cis isomer has a dipole moment, higher dipole moment than the corresponding trans isomer, right? So here we have a cis 2,3 dichloropromo pentane 2-ene higher dipole moment as compared to the trans 2,3 dichloropentane 2-ene. So this is how we can actually define the some general property of cis and trans isomer. So I hope this is clear to everyone. That is how will you calculate the boiling point, melting point, solubility, and the dipole moment of cis and trans, and what are the reason behind this? Which one having the maximum value, which one having the minimum value? So I hope this is clear to everyone, right? Now, geometrical isomerism in the cyclic compound. So this is one of the most important and also very important to remember, right? That is the geometrical isomerism in the cyclic compounds. So what are the geometrical isomerism in the cyclic compound basically? So the geometrical isomerism is also possible in the cyclic compound as no free rotation is possible, right? So geometrical isomerism is also possible in the cyclic compound as no free rotation is possible about carbon-carbon single bonds in such compound, right? Thus, for the rotation, bond breaking is required, which result in the ring cleavage. And, right, remember this point, geometrical isomerism is also possible in cyclic compound. How? As no free rotation is possible about carbon-carbon single bond. Here, there is no free rotation. This group and this group cannot be rotated. This group and this group cannot be rotated. So here the free rotation cannot be possible about the single bond in such compound. Thus, for the rotation, bond breaking is required. अगर आपको rotate करना है, then must bond breaking is required, which result in the ring cleavage. अगर bond टूटा तो किसमें result होगा? Ring cleavage में. That is 1,2-dimethyl cyclopropane. 1,2-dimethyl cyclopropane exists in the following two isomeric form. कौन से दो isomeric form बेटा? इस वाले. That is we have 1,2-dimethyl. We have 1,2,3. So 1,2-dimethyl cyclopropane. They exist in this two forms. So here we can say that the CH3 and CH3 both are above. So we can say that this is a cis. Here CH3 is downward and CH3 is upward. So we can say that this is a trans isomer. So we can also classify cis and trans isomer in the cyclic compounds. Okay. Now, this is a question come in the JEE in 2020 examination, and you are they are asking among the following compound geometrical isomerism is shown by. So फटाफट जल्दी से बताओ, वही दो कंडीशन याद रख के, there is no free rotation, two different groups are present. So ये सब ध्यान में रख के बताओ, among the following compounds geometrical isomerism is exhibited by. किस में से कौन है जो geometrical isomerism को exhibit करेगा? फटाफट. I'll giving you 30 seconds for this question. Try to give me the correct answer for this question. You just need to find the geometrical isomerism. Which of the following out of these four options, which of the following compound will show geometrical isomerism? फटाफट. सी. जीएनवी सिमोगा ने बोला है सी. Anyone else? पहला कंडीशन देखो कि दो डिफरेंट ग्रुप मस्ट बी अटैच्ड टू एनी टू कार्बन एटम ऑफ रिस्ट्रिक्टेड रोटेशन. यहाँ पे रिस्ट्रिक्टेड रोटेशन है. सो चलो मैं देखता हूँ यहाँ पे अगर रिस्ट्रिक्टेड रोटेशन है, मान लो ये कार्बन हो गया, राइट. सो यहाँ इस वाले कार्बन पे तो दो सेम ग्रुप आ गए ना, एच और एच. तो दिस इज नॉट पॉसिबल. ना यहाँ पे आओ, तो ये मान लो कार्बन है, तो कार्बन कार्बन डबल बॉन्ड. हियर वी हैव अ टू ग्रुप. कैसे दो ग्रुप है जल्दी बताओ, मैं इसको ड्रॉ करूं. लेट मी ड्रॉ. So in this carbon, we have a two different group, right? We have a two different group like H and Cn. What about this carbon? In this carbon also we have a two different group. Yes. बिकॉज अगर आप इधर से जाओ तो क्या आ रहा है, 1 2 3 4 आ रहा है। इधर से जाते हो तो इधर पे हो तो इधर जा रहे हो 1 2 3 4 5। इधर से जाते हो तो 1 2 पे मिथाइल ग्रुप आ रहा है, तो दोनों पे अलग अलग आ रहा है ना। इधर से अगर आप जा रहे हो तो 1 और 2 पे कुछ भी नहीं लगा हुआ है, इधर जा रहे हो तो 1 और 2 पे एक मिथाइल ग्रुप लगा हुआ है। तो आप देख रहे हो इस कार्बन के इधर एक अलग ग्रुप, इधर एक अलग ग्रुप, और इस वाले कार्बन पे भी दिस इज अ डिफरेंट ग्रुप, दिस इज ऑल्सो अ डिफरेंट ग्रुप। सो दिस कैन शो, राइट, सो दिस विल शो ज्योमेट्रिकल आइसोमेरिज्म। व्हाट अबाउट दिस, ये शो क्यों नहीं करेगा? देखो, we have this, so we have a two different group on this carbon, this is okay. But now what about this group? इधर से भी जाओ तो यही मिल रहा है, सेम, ठीक है। इधर से भी जाओ तो यही मिल रहा है, सेम। So on both hand they having the same group, so you can say that this will not show the geometrical isomerism. This also, they have, इधर से भी जाओ तो आप देखो, this is carbon, so this is 1 और 2, this is 1 और 2, तो 2 पे सेम ग्रुप है, तो इधर से भी जा रहे हो तो सेम ग्रुप है। देखो इधर से भी अब जा रहे हो तो सेम ग्रुप है, इधर से भी जा रहे हो तो भी सेम ग्रुप है। दैट्स व्हाई ओनली बी विल शो द ज्योमेट्रिकल आइसोमेरिज्म। इज इट क्लियर टू एवरीवन और नॉट? अगर नहीं है क्लियर तो पूछो एक बार फटाफट। दिस इज क्लियर एवरीवन? व्हाई ओनली बी शो ज्योमेट्रिकल आइसोमेरिज्म? Among the following compounds, why only B show geometrical isomerism? Is this clear to everyone? Confirm me once फटाफट जल्दी से confirm करो। If you want to understand, then I'll repeat this once. No issue. Just tell me. Basically, in this question, they're asking among the following compounds, geometrical isomerism is exhibited by, right? They're asking which will show geometrical isomerism. So we know the basic concept for the geometrical isomerism. What are the basic concept are, beta? That is, must be carbon-carbon double bond is must be there, right? Carbon-carbon double bond must be there. That is restricted rotation, and on carbon, two different groups must be there. Either in first carbon we have H and Cl, and if you compare this carbon, then also we have a different group like 1 2. So in 2 we have a methyl group, but if you move from here 1 2, you do not have any methyl group, so these two having a different groups, right? So we can say that this will show the geometrical isomerism because they fulfill the criteria for the geometrical isomerism. Now, just like the geometrical isomerism, we also wants to learn optical isomerism because this is also the part of the stereo isomerism. So we know what is geometrical isomerism. We already cover their requirement. What are the basic need for the geometrical isomerism and how will you name this, like phase trans and all this thing, right? Now let's move to the optical isomerism. So basically the compounds with the similar or dissimilar physical as well as the chemical properties and with marked differences in their behavior towards the plane polarized light are called optical isomers. And there this property is called optical isomerism, right? So basically, the compounds with the similar or dissimilar physical as well as the chemical properties and with marked difference in their behavior towards the PPL, that is plane polarized light, are called optical isomer. And there, this property is called optical isomerism. Before going in detail, it is better to understand some terms related to this isomerism, right? That what are the terms that we are using continuously if you're describing about the optical isomerism. So optical isomerism is clear, I hope. That is a compound with the similar or dissimilar physical as well as the chemical properties with marked difference in their behavior towards the plane polarized light, right? If they show different behavior with the PPL, plane polarized light, then they are so said to be optical isomers. Now, let's see some key terms related to the optical isomerism, right? What are the key terms related to this optical isomerism? Now, the first important terms related to optical isomerism is polarized light, right? What do you mean by this term, polarized light? So let me tell this. This is very important. So according to the wave theory, an ordinary ray of light is considered to have a particular vibration in all possible planes, perpendicular to its path of propagation. However, in polarized light, the particulate vibration occur only in the one plane only. So basically, polarized light means ये कि ये देखो ये unpolarized light है. The light coming from the bulb, the light coming from the sun, they all are the unpolarized light, right? So यू कैन कंसीडर कि जैसे सब लोग चश्मा लगाते हैं, गॉगल्स लगाते हैं, अच्छी क्वालिटी के चश्मे की बात कर रहा हूँ मैं, गॉगल्स लगाते हैं तो क्या करता है, गॉगल्स लगा के फिर अगर हम ऊपर देखते हैं तो हम ऊपर की जो सनलाइट है उसको भी अच्छे से देख पाते हैं, है ना। लेकिन अगर बिना गॉगल्स के देखें तो लगता है हम देख नहीं पाएंगे, ठीक है। तो दे आर अनपोलराइज लाइट। उस गॉगल्स में क्या होता है, उस गॉगल्स में लगा होता है पोलरिमीटर टाइप, पोलराइजर लगे होते हैं। वो पोलराइजर क्या करते हैं, व्हाट द यूज ऑफ दिस पोलराइजर, पोलराइजर मेक दिस अनपोलराइज्ड लाइट इनटू पोलराइज्ड लाइट। पोलराइज्ड लाइट का मतलब होगा कि देयर वाइब्रेशन इन ओनली इन वन डायरेक्शन, राइट, नॉट इन द रैंडम डायरेक्शन। So unpolarized light is a natural light which having vibration in all the direction, but the polarized light having only in one direction, right? So this is the path of the propagation and unpolarized light, and this is the polarized light. So I hope it is clear how unpolarized light is converted into polarized light by using some polarimeter or any polarizer. So this is all about the polarized light. Now, the next thing is optical activity. So what is this optical activity basically? How will you learn this optical activity, right? So what is this optical activity? So the property of a compound by virtue of which it can rotate the plane of polarized light, it is called optical activity. And such a compound is called optically active. Always remember the property of the compound by virtue of which it can rotate the plane of polarized light is called optical activity. And such a compound is called optically active. Right. Now, what about the asymmetric carbon atom? So the carbon atom which have the four different groups or atom attached separately to its four valencies is called symmetric carbon atom. Clear है? So this is all about the optically active and asymmetric carbon atom. ठीक है? That is the carbon atom which have the four different groups or atom attached separately to its four valencies are called asymmetric carbon atom. So optically active is clear and asymmetric carbon is also clear. Now, what is chiral molecule? So this term is very important if you learn about the optical isomerism. Then this term, that is a chiral molecule, is very important. So what is this chiral molecule? So a molecule completely lacking plane of symmetry is called chiral molecule, right? So important to learn, a molecule which is completely lacking plane of symmetry is called chiral molecule. In other words, it can also be defined as the molecule which is not superimposable on its mirror reflection or the reflection on which the line of symmetry is lacking. Asymmetric and chiral bonds are the synonyms. Hence, asymmetric carbon will generally be considered as the chiral carbon. Always remember. What is a chiral molecule then? A molecule which is superimposable to its mirror image. For example, this one. This is our hand, right? So this is thus it is impossible to this or not, because the mirror image of this is what? This is the mirror image. So this is not impossible. They are not superimposable to each other. So they are called chiral molecule, right? They are not superimposable to each other. On the similar basis, how will you define the element of symmetry? Right. So the term related to the following elements of symmetry are frequently used in the optical isomerism. Like plane of symmetry, center of symmetry, and the axis of symmetry. So what is the plane of symmetry? So here we can say that this is the plane of symmetry. How? Because if you know break this part, you'll get the same at the above and below. Both are same. They having B, C and A, B, C and A. So this is called plane of symmetry. So always remember what is plane of symmetry? The plane which divide in a equal parts, right? जो plane equal parts में divide कर दे उसको हम लोग क्या बोलेंगे? Plane of symmetry. Similar, what is the center of symmetry? So center of symmetry means here we have a no center of symmetry, right? But they has a center of symmetry. Here this is a center of symmetry. ठीक है? ये यहाँ से आया, यहाँ से बिल्कुल कट गया, देखो ये यहाँ से बिल्कुल कट गया, ये यहाँ से बिल्कुल कट गया, ये यहाँ से कट गया. So they having the center of symmetry. So those do not having the center of symmetry and those having the center of symmetry. So these two are very important elements of symmetry, plane of symmetry and the center of symmetry. The next one is axis of symmetry. So this is the axis of symmetry we have, like x. If you break this from here, then we'll get this axis of symmetry, right? So this is the axis of symmetry. Along this axis only they will rotate. So if you break along this axis, x and y, will get the axis of symmetry. So, what is optically active? If you know this term, that is what is the element of symmetry, a chiral molecule, asymmetric carbon, optical activity, polarized light, then how will you define the optically active compounds? So, those isomers which have the ability to rotate the plane of polarized light are called optically active isomer. Always remember, right? So, those isomers which have the ability to rotate the plane of polarized light are called optically active isomer. These isomers are in fact chiral. Chiral means what, beta? They do not have the element of symmetry. Always remember, for the compound to be optically active, they must have chiral, right? These isomer are in fact chiral. It means don't have the element of symmetry. So among the octally active isomer, following two types are included. One is known as dextrorotatory, also represented as D or plus form. Another is known as the labororotatory or L, or it is denoted by negative form, right? Which rotate the plane of polarized light to the left hand side, or we say anti-clockwise. So dextrorotatory means क्या हो गया? Which rotate the plane of polarized light to the right hand side or the clockwise direction. And the levorotatory or L का मतलब क्या हो गया? Which rotate the plane of polarized light to the left hand side or anti-clockwise. ठीक है? So this is the definition of the optically active compound, dextrorotatory and the levorotatory. Now, then what is optically inactive? What do you mean by this term, optically inactive? So those isomers which do not have such an ability, which do not rotate the plane of polarized light, are called optically inactive isomers. Okay? So those isomers which do not have such an ability, that is, which do not rotate the plane of polarized light, are called optically inactive isomer. The reason for the inactivity of this isomer may be one of the following, that is presence of element of symmetry, or we say presence of D and L forms in the equal amount. So these may be the reason for this, right? That is those isomers which do not have such an ability, which do not rotate the plane of polarized light, are called optically active isomer, right? Now, tell me some question related to this geometrical and optical isomerism. So the first question is, which class of compound can exhibit geometrical isomerism? फटाफट बताओ. Out of the four option or all of them, which class of compound can exhibit geometrical isomerism? फटाफट बताना है सबको. बताओ भाई जल्दी से. ए. ठीक है. अभी चेक करते हैं फटाफट. सो दिस इज ना इमीन फॉर्म ना, अभी भी बात किया था कि कार्बन और नाइट्रोजन का डबल बॉन्ड हो, यहाँ पे ऑक्साइम OH लगा हो, तो कार्बन नाइट्रोजन डबल बॉन्ड है. ये N पे OH लगा हुआ है, और यहाँ पे क्या है बेटा, C पे एक H फॉर्म है, और एक है C6H5. सो एक है C पे H फॉर्म, एक है C6H5 डबल बॉन्ड NOH. सो ये कौन सा फॉर्म शो करेगा हम लोगों को? They will show the geometrical isomerism, right? So they will show the geometrical isomerism. Now the next one is, we have like CH3CH. So this will show or not? Let me check. So this is T double bond C. This is H. This is CH3 again. This is again H. This is CH3. So this will also show the geometrical isomerism. Whether they will show or not. So we can say that this is what? This is HOOCCH. Right? C and CH. CH, and here we have CH2, we have CH, COOH, right? And from this compound, that is C, to this compound, the C, uh, yeah, C, they have the cyclic nature. So it will show or not. So definitely they show geometrical isomerism. So we can say that all of them show geometrical isomerism. Option A, B, and C. All of them will show geometrical isomerism. Now, which of the following has the geometrical isomerism? इसमें से बताओ. किसमें ज्योमेट्रिकल आइसोमेरिज्म है? 1,2-डाइक्लोरोइथेन, 1,2-डाइमिथाइल साइक्लोप्रोपेन, या CH3CHCONH, CH3NHCO, या ऑल ऑफ द अबव? फिर जल्दी से बताओ। 1,2-डाइक्लोरोइथेन कैसे बनाओगे स्ट्रक्चर? 1,2-डाइक्लोरोइथेन, 1,2-डाइक्लोरोइथेन, HCl, so this is 1,2-dichloroethane. So this will show, definitely this will show. The next is 1,2-dimethyl cyclopropane. How will you draw the structure? 1,2, 1,2-dimethyl cyclopropane. 1,2-dimethyl cyclopropane. So here the structure is like HCH3, HCH3. So this is also, this is a cyclic two different group at the adjacent position, so exhibit geometrical. So this will show GI. This will also show GI, right? In GI, they show cis and trans, right? Now, what about the next thing? That is CH3, CH, and CONH, and NHCO, COCH3. So this is a cyclic compound, but they will not show. So whether they will show or not. So we know that which of the following show geometrical. So again, this is a cyclic. So we know that the cyclic single bond also restricted motion. They will also show the GI. So they will also show. So out of this one, B and C also. So we can say that D is the correct option, right? That is all of them show geometrical isomerism. Now इसका आंसर बताओ फटाफट जल्दी से। क्वेश्चन नंबर 38, which will form geometrical isomerism? जल्दी से बताओ फटाफट। Which will form geometrical isomerism? A, B, C, or D? All of these. No one? Try to answer this question, बेटा. This is a simple one. चलो पहले जो बताते हैं, ये तो देगा, अभी भी बताया था. This is an oxime form, carbon imine form. This will show, right? Now what about this? What about this? So in the later part, you're going to know this is, whenever the more than one carbon, seven carbon is there. This is carbon number 1, 2, 3, 4, 5, 6, 7, 8, 9, and wait. And this is 10. So this will also show, because if you consider this, here we have a carbon, here we have a carbon. So this is a restricted rotation motion. And if you go from there, this is pointer, that is over 3, 4, 5, 6, 7, and from here you'll get the different position, right? So this will show the GI as well. This will also show. What about this? This is a cyclo. This is a cyclo compound. Will they show geometrical isomerism? Just like this. We already discussed this thing. We have one CH3H here and one HCH3 here. So this will show GI. Whether this will show GI or not. Tell me whether this will show GI or not. Anyone? Yes, definitely. This will also show GI. So we can say that all of these. So जब भी तीन क्वेश्चंस किए हैं, सबका आंसर यही है, all of these. So all of these will show GI. Now, question number 39. So in the double bonds are, अब आपको बताना है डबल बॉन्ड सिस में है या ट्रांस में है. So double bonds are in cis position or trans position. Tell me fast. Suppose you have a carbon here, carbon here, carbon here, in carbon here, carbon here. So you need to find the double bonds are in cis trans, trans trans, cis cis और trans cis. क्या होना चाहिए? बताओ फटाफट, ध्यान से देखो, क्या इसमें आइडेंटिकल दिख रहा है? सिस कब बोलोगे? सिस जब बोलते थे जब दोनों साइड पे सेम होते थे। हम्म। दिस इज सिस। और ट्रांस कब होता था? जब अपोजिट होते थे। बताओ। इन दिस द डबल बॉन्ड्स आर सिस सिस, ट्रांस सिस, सिस ट्रांस और ट्रांस ट्रांस। देखो, पहला डबल बॉन्ड, दूसरा डबल बॉन्ड, तीसरा डबल बॉन्ड। तो ध्यान से देखो, इसमें फर्स्ट और थर्ड वाला जो है, दैट इज द फर्स्ट एंड थर्ड बॉन्ड्स आर आइडेंटिकल। सेम दिख रहा है फर्स्ट और थर्ड बॉन्ड। तो फर्स्ट एंड थर्ड बॉन्ड्स आर आइडेंटिकल, फर्स्ट और थर्ड बॉन्ड आर आइडेंटिकल एंड द सेकेंड वन इज डिफरेंट। या सी, दैट इज ट्रांस एंड सिस। वेरी गुड बेटा, राइट, दैट इज ट्रांस एंड सिस। सो ये कौन सा फॉर्म शो कर रहे हैं? ट्रांस एंड सिस। सो दीज ऑल आर द इंपॉर्टेंट क्वेश्चन फॉर यू। ठीक है, तो आई गेस सबको समझ आ गया होगा कि किस तरीके से हाउ यू आइडेंटिफाई द ट्रांस एंड सिस। सो नंबर ऑफ ज्योमेट्रिकल आइसोमर फॉर द मॉलिक्यूल, इसमें आपको बताना है नंबर ऑफ ज्योमेट्रिकल आइसोमर। दिस इज द लास्ट क्वेश्चन, फटाफट बता दो। देखो चलो मैं एक्सप्लेन करता हूँ। फॉर सच टाइप ऑफ कंपाउंड, अगर ऐसे कभी आ जाता है नंबर ऑफ ज्योमेट्रिकल, बिकॉज यू नो ओनली सेज एंड ट्रांस, राइट, टिल नाउ यू ओनली नो सेज एंड ट्रांस। So always remember n is the even number of the two identical ends, right? So number of geometrical isomerism, तो जब भी geometrical isomerism calculate करना होगा, always use the formula 2n minus 1. Later we are going to discuss all this thing in the next class, right? This is n by 2 minus 1. So what is n here? So we can say that n, that is the even number of these two identical ends, right? So even number of these two identical ends. So always remember, if n values is 1, that is 2, 2 minus 1 plus 2, 2 divided by 2, right? N by 2, na? That is, yeah, minus 1. So this will become 2 raised to 2 minus 1, that is 1. This is 1 minus 1, that is, uh, yeah, that is 2, 2 minus 1. So how will you say that? This is 2 or plus 1, that is 3. That is 3. So this is how we do calculate. So this formula we are going to describe in the next class, right? How this formula will come and how will you get to know whether you have to apply this formula or not, right? So this formula we also use for calculating the GI. So this formula we're going to see in the next class, right? So this question is from the AIEEE 2009, very old question. I hope all of you able to solve this question. So this is a homework question for you all, right? The alkene that exhibits symmetrical isomerism. It's a very simple question. The next is, which of the following compounds show symmetrical isomerism? This will come in JEE in 2020. So this is also homework question for you. Note कर लो फटाफट, जल्दी से note करो. Which of the following compounds show symmetrical isomerism? Right. So this is all about the, yes. Anyone having any kind of doubt, you can ask. फटाफट पूछ लो, किसी को कोई भी डाउट हो अभी तक? नो? Chalo. So should we end this meeting, right?